they're similar to fractions. We can simplify them by canceling out the common factors from numerator and denominator. So basically, to simplify rational expressions, we follow these two steps. We factor the common things in numerator and denominator, and then we divide or cancel out the common factors. So let's look at some examples. I have 2x minus 2 over x squared plus 8x minus 9. So to simplify this, the common thing in 2x and 2 is 2, so I factor out the 2 and I get x minus 1, and on the denominator I have quadratic equation. To factor this out, two numbers that when I multiply them I get negative 9, and when I add them I get positive 8 are negative 1 and positive 9. So on the numerator I have 2 times x minus 1 over, and on the denominator I have x minus 1 times x plus 9. So the x minus 1 from numerator and denominator cancel each other out. So what's left is 2 over x plus 9. And that's how we simplify rational expressions. Alright, so let's take a look at this example. I have x plus 3 over x squared plus 12x plus 27. So in the numerator, I don't have actually anything to factor out. I just keep it as it is, x plus 3. But on the denominator, this is quadratic equation. Two numbers that when we multiply them, we get 27, and when we add them, we get 12. It looks like 3 and 9. And both of them are positive. So x plus 3 from numerator and denominator, I can cancel it out. And what's left on numerator is a 1, so don't forget to write that. And it's 1 over x plus 9. Alright, so this example is for you guys to try. I have x squared minus 4x over x squared minus 8x plus 16. So try to simplify this, we'll go over it together. Alright, so the first thing is that this is a really big mistake that some students cancel out this x squared and this x squared. This is one thing and this is another thing. So we can't cancel just a part of it. So let's see what we can do. The common factor in these two is 1x. So I factor 1x and I get x minus 4 for numerator. And for the denominator, I have x squared minus 8x plus 16 and quadratic equation. So let's factor it out. Two numbers that when we multiply them, we get positive 16, and when we add them, we get negative 8. It looks like negative 4 and negative 4. So I can cancel one of the x minus 4s from denominator and with the one that I have in the numerator. So what's left on numerator is just 1x over x minus 4 for the denominator. So, alright, so we have this example, x squared plus 10x plus 24 over x cubed minus x squared minus 20x. So for the numerator, two numbers that when we multiply them, we get 24, and when we add them, we get 10. It looks like x plus 4 and x plus 6. And for the denominator, the first thing that we're going to do is to factor out 1x, because I have 1x in all of them. So if I factor out an x, I get x squared for the first term. For the second one, I get an x and a negative 20. So for denominator, I have x times x squared minus x minus 20. And then I keep the numerator as it is. I keep the x, and then for this big parentheses, I have negative 20. So two things that when I multiply them, I get negative 20, and when I add them, I get negative 1. It looks like positive 4 and negative 5. So I can cancel out a negative, I can cancel out 1x plus 4 from both top and bottom. And what's left for the numerator is x plus 6, and for denominator I have x times x minus 5. You can also multiply the x to distribute the x to the parentheses, but it's common to leave the answer as like this, factored like this. So that's that. Okay, so let's look at this example. I have x squared minus 36 over 12 minus 2x. So for x squared minus 36, we can use difference of squares. So a squared minus b squared is equal to a minus b times a plus b. So if my a is x and my b is 6, I can write that as x minus 6 times x plus 6. And then for the denominator, I can factor out a 2, and I would get 6 minus x. So here, if you look at it, this looks like the same thing, x minus 6 and 6 minus x, but there's a negative. So if I factor a negative from this, I can get, let's write that one more time, x minus 6 and x plus 6 for numerator, and then if I factor out a negative 6 from a negative 1 from here, I get negative 2 times x minus 6. And then I can cancel out the x minus 6 from both top and bottom, and I get x plus 6 for numerator and a negative 2 for denominator. Or I can write it as negative x plus 6 over 2. It really doesn't matter where you write the negative. Alright, so I have this example for you guys to try. So I'm going to read it for you. X cubed minus 27 over x squared plus 3x plus 9 times 9 minus 3x. Go ahead and pause the video, try to do this. You can also use this property here to solve it. We'll go over it together. Alright, so for the top part, this is x cubed minus 27. It looks like this one, but my a is x and my b is 3. So to factor out that, I can write it as x minus 3 times x squared plus 3x plus 9. And for the denominator, I have x squared plus 3x plus 9 times. And for this part, I can factor out a negative 3. So if I factor out a negative 3, I get x minus 3. So let's try to cancel the common factors. This one looks like this one, so I can cancel these two. And then the x minus 3 and x minus 3, I can cancel them. So what's left for numerator is just a 1. Don't forget to write the 1. And for denominator, I have just negative 3. So it's 1 over negative 3 or negative 1/3. Alright, so that's it for rational expressions. Thank you for watching.